So good morning, good afternoon, good evening, colleagues. I would like to start now. I see that we have 131 participants at this point, and I figure that number is going to go up in the next few minutes. But let's begin our first webinar. So hello, and welcome to UNICEF's webinar series on data collection, which is organized by the Data and Analytics section at UNICEF headquarters. I'm Attila Hancıoğlu, Chief of the Data Collection Unit in the Data and Analytics section. We begin this series today with two back-to-back webinars by two distinguished speakers. We intend to run this webinar series until the end of October, every Wednesday, starting at this time, with either one or two webinars each week. And each webinar session will be on one or more data collection methods. The emphasis in these webinars will be on methodology as opposed to sectoral topical content. But of course, while discussing the methodologies, we will have to discuss the sectoral and topical contents as well. As we all know, the COVID pandemic triggered an exponential increase in data collection, an unprecedented uptake of non-traditional data collection methods and use of technology. As UNICEF, we are very much involved with such activities worldwide. There has been a very clear demand from our offices around the world to provide guidance on various data collection methods. In response, as the Data and Analytics section, we are now establishing a light guidance mechanism. The webinar series is one of the activities in this guidance mechanism. All webinars will be recorded and uploaded to a SharePoint site, just that you know, together with background notes on various data collection methods, reading materials, a questionnaire bank, and we will have a dedicated team member who will respond to all queries around data collection methods. So with that very brief introduction, let us now begin our first webinar today. Throughout the webinar, some ground rules. Throughout the webinar, please remain muted, but please write your questions in the chat box. Our speaker will have a chance to answer your questions as time permits. The first webinar today is on the use of social media advertising data. Our speaker is Ingmar Weber from the Qatar Computing Research Institute. Ingmar will present for 40 minutes, and we will then have a Q&A for 15 minutes or thereabouts. We will aim to end 5 minutes before the scheduled time to move to the next webinar, which had a separate Zoom link, as you know. For our first speaker today, Ingmar is the Research Director for Social Computing at the Qatar Computing Research Institute. Ingmar's interdisciplinary research uses large amounts of online data from social media and other sources to study human behavior. His particular topics of interest include quantifying international migration using digital methods, tracking digital gender gaps, mapping social inequalities, and precision public health. Before joining the Qatar Computing Research Institute, Ingmar studied and worked at the University of Cambridge, the Max Planck Institute for Computer Science, École Polytechnique Fédérale de Lausanne, and Yahoo Research. Ingmar's research has been cited over 7,000 times, and he serves as an ACM distinguished speaker. I would like to thank Ingmar to begin with for agreeing to present in our webinar series. Ingmar, please share your screen. The floor is now yours.
Great. Thank you so much, Attila, for the introduction. Yeah, let me start sharing my screen. Great. Yeah, and thanks all of you for attending. I know for many of you it's quite early in the morning. Yeah, so as Attila mentioned, so this is a very methodological presentation. So I will focus on one particular data source, which is social media advertising data. And I will start by sharing I mean, I'm already sharing my screen, but by showing you something live, and then I'll later, talk about how we actually use this type of data. So what I'm showing you at the moment is Facebook's advertising platform. So this is publicly accessible as long as you have a Facebook account, and it's also free of charge until you actually get to the point of actually launching an advertising campaign. Right. So here I'm showing you that I'm at the step of selecting the audience of my eventual advertising campaign to launch, or not. I mean, I don't have to launch the campaign, of course, right? And so here I'm currently targeting people living in a particular location, but I could also only limit it to people traveling in a location. But let's stick with living in, because that's typically what you are after in most data collections. The area that I'm targeting is Accra, so in Ghana, and I'm targeting the whole city as such, ages 13 and above, all genders. Just move this out of the way. And then the crucial thing is that before you launch your advertising campaign, Facebook provides information on how many people match your targeting criteria. Right. So here up here it says 3.5 million. So think of it as a sort of like a real-time digital census over Facebook users, right? So you can ask questions like how many Facebook users match certain criteria, right? So for example, if you're interested in gender gaps, you can look at, of these 3.5 million people, how many are women? Okay, so let's select this. So it's only 1.3 million, right? Which is considerably less than half, right? And this is one of the things that I'll talk about. This tells you something about gender gaps, in this case, in Ghana. If you're interested in migration, you can look at how many of these, in this case, women now living in Ghana, used to live in Nigeria. Okay, so now this goes down from 1.3 million to 19,000. Okay, so this tells you something, about sort of migration background, right? Sort of also. And now, if you wanted to understand this further and look at the sort of socioeconomic situation of these people, you can look at of these women who used to live in Nigeria, who are now living in Accra, how many are using or predominantly using an iOS device to access Facebook. So iOS devices are typically more expensive, which is a signal for socioeconomic status. And I'll get back to this later, right? So now it goes down to sort of 3,000. And again, the absolute number might not tell you much, but if you sort of compare this across sort of different subgroups, like the percentage of people using a particular device, you actually get relevant insights. Right? So these are the three key things that we use related to gender, migration, and socioeconomic situation. There are a few more that I'll briefly mention. So there are targeting attributes related to 4G or Wi-Fi, etc. sort of. So, and those also relate to socioeconomic situation. There are things related to how long somebody has been using a mobile device. So this sort of relates to, well, yeah, time, I mean, like experience online, you could say. And there are many other sort of targeting criteria, but I'll just sort of stick to those in my presentation. Okay, so now what can you do with this? I'll just show you sort of some sort of fun data visualizations first. So this is first for New York City. So suppose you didn't have any data at all about New York City. This was an unknown, sort of black data hole sort of also for you. And you want to understand, let's say, the wealth distribution in this sort of city, right? Then you can look at the distribution of iOS devices in terms of sort of density, right? And you see that sort of also lower Manhattan, Midtown, or sort of also you have about 90% of Facebook users using iOS devices to access Facebook, right? Whereas in the Bronx, this goes down to about sort of 40%, right? So you get some sort of like rough relative insight. You would sort of probably rightly assume that this area is doing quite a bit better than this other area, right? It doesn't tell you precise dollar value, of course, but sort of so for relative comparisons, it seems to be quite robust, right? Or looking at a migratory background, if you wanted to understand, so people who used to live in Latin American countries, where do they live now? So the density, of the total population, again, is sort of highest, again, sort of in the Bronx and neighboring areas, where about sort of 40% of Facebook users used to live in Latin American countries. Oh yeah, I should say this data visualization that is publicly accessible, and I will later drop the links in the Skype chat, is created by us, but using the sort of Facebook data that I showed before. And this is not live data. The data was collected in this case already quite some time ago in 2017. Now here I'm showing New York City, and you have open government data in New York City. So, I'm not showing you anything that you couldn't, know and probably know better using different data sources. But in other parts of the world, that's not the case, right? Like even in Doha, where we are based, there's not a lot of sort of subnational open government data, right? So if you wanted to understand, let's say, the situation of the Nepali migrant workers, again, you can look at Facebook data. Where do people live now who used to live in Nepal? They primarily live in this part of town called the industrial area, which anecdotally is true, but again, there's no official data sort of like I could use for formal validation. They're almost all men. Again, these are blue-collar migrant workers who typically don't make enough income to bring over their families. And they're almost all Android device users, right? Very few of them could use or could afford an iOS device. And they're also fairly young, which is actually now a blessing in the context of COVID-19, because it means that the mortality is actually quite low because the population in the country overall is quite young. Other people who used to live in Western European countries or North America, they live in a very different part of town, right? This is where I live, again, not coincidentally, roughly gender balanced, right? Sort of, so I'm there with my wife and family. You have older people, sort of knowledge expats, and you have more iOS device users than Android device users, right? So again, you get like in rough strokes, get a sense that this is a very, very different life experience, sort of, so that these two groups are experiencing, right? Again, conceptually, you can do this for any part of the world, sort of, so I'm just showing like one. I mean, I don't want to go through this like data visualizations, sort of, so here I'm showing data for Lagos. Let's look at wealth, maybe, sort of, so as a proxy. So in Lagos Island, where I understand this is where the government is located, you have, compared to other parts of Lagos, relatively high iOS usage, about 15% of Facebook users, whereas in other parts of Lagos is considerably lower, sort of between like 5 and maybe 7%, right? And also in terms of gender distribution, you'll see that here you have considerably fewer women on Facebook. Here it's only about like 1/3, whereas here it goes up a bit higher, sort of, right? And so then the last thing, before actually going through the sort of application, I would say is that even though I'm basing this mostly on Facebook data, you can do this for anything at all. Again, I repeat, anything at all that has targeted advertising. So here I'm just showing Twitter's Twitter's advertising platform. In this case, it's for sort of, well, teenagers and above, sort of 13 to 24-year-olds living in the Philippines. You can look at the gender distribution. So out of 2 to 2.5 million users, this actually skews female. So you actually see that here. I think the slight majority, if I remember, is actually it's actually skews slightly female, among young Twitter users in the Philippines. You can do this for Snapchat, LinkedIn, whatever, So I won't go through all of this. Maybe if there's time later, I can show a few more examples for other platforms. So this is the most important, but just again, just understanding what you can obtain sort of through these platforms. And even though here I showed it sort of by hand, and these platforms offer so-called APIs, so you can very easily write a computer program to collect like hundreds and thousands and millions of these data points. But of course, to show the data source, it's probably easiest to do it by hand. Okay, so now on to some examples. Let me just keep track of time. Great. So yeah, here are the people at QCI who are contributing to this work. But as you see, there are a lot of people contributing from other places, including actually UNICEF. And I'll mention those in a second. So I'll talk about 4 applications. So one is on migration, one is on mapping poverty, one is on digital gender gaps, and one is sort of like a sort of hybrid between poverty mapping and migration monitoring. Okay, so let's start with the work on the Venezuelan exodus. So there are a number of collaborators involved here at UNICEF sites, at UNICEF's end. This was Natalia Adler, Vedran Secara, and Manuel Garcia Herranz. Background, I mean, I'm sure here, you're familiar with the, rough situation in Venezuela, and these numbers might not even be up to date. I think they might be already like maybe a couple of months old. But at that point, annual inflation in Venezuela was more than 10,000%. Unemployment was more than 35%, and importantly, the minimum wage. So if you paid every single dollar or peso of your wage on food, it would only buy you about 1,000 calories a day, right? So people were and are literally starving, and so as a result, many people have left the country. And precise data on some of this, I guess, is getting better as time goes on, but especially 2 years back or a year back. Data was still more patchy, let's say. And so here what I'm showing is data that we collected systematically from 2018 onwards, but also we have a single snapshot going back to 2016 on using Facebook data on the number of people who used to live in Venezuela, again, according to Facebook, and at that point in time were living elsewhere. Okay, so elsewhere, let's look at first at this data in red, which is Colombia. Okay, so here you have something that goes up a bit over time, and it seems to go only up a bit, but this is actually a logarithmic scale to sort of to show you know, sort of other things, you know, other countries as well. So it goes, I think this value is like maybe 1.2 million. It goes to like 1.5 million or so as of that point. And then I think currently it's, I think, around 1.6 million. So it hasn't increased a lot further since. So this is this. So at the bottom you have just the raw numbers as provided by Facebook's advertising platform. At the upper end of this band, you have an attempt to correct for the fact that, of course, not everybody is on Facebook, right? Like obviously, sort of. So we know this, right? We're not assuming this, sort of. And so we are sort of trying to correct for the fact that you know, there are sort of false negatives, right? Sort of. So we are assuming that the Facebook penetration among Venezuelans living in Colombia is the same as in the total Colombian population, because we cannot actually compute the penetration among the migrants and refugees because we don't know their precise number, but we have a rough idea of the total, you know, population in Colombia, and we know through this advertising platform how many of them are on Facebook, so we can actually compute the latter. So we are making this assumption, and then we are sort of correcting upwards for the fact that not everybody in the group is on Facebook. So this is sort of so now an estimate assuming that there's not a single false positive. This would be sort of the true estimate, right? And likewise for the other sort of countries. And then here, these data points in red. So we are trying to validate this now. Is this actually sort of true, right? Is this just sort of, you know, random numbers generated for whatever reason? And here you have estimates from different UN reports. And by and large, actually, sort of, so these Facebook values are fairly close to what you know, sort of more official data report. If anything, Facebook would probably suggest that the true numbers are a bit higher than what you might expect from these reports. So that's sort of encouraging. Now, in terms of further validation, so when you now look subnationally, and again, part of the reason that it's hard to validate some of this data is that often there isn't a lot of ground truth data to begin with, right? Which is the whole reason to look at this data for triangulation purposes. So here I'm showing on the left data from the Colombian government. So this is based on a self-registration, voluntary self-registration of migrants and refugees throughout the country. And on the right, collected around the same point in time, the spatial distribution of these Facebook users who used to live in Venezuela, who now living, or at that point in time were living in Colombia. And you see that there's some sort of similarity, right? That there's more on the border, but there's also certainly differences, right? That according to Facebook, that you'd have a higher number, or you know, higher density, sort of also further inland, just away from the border. And because we worked with people in Colombia, in particular through IMAP, they actually, the feedback we got is that actually the data from Facebook is probably closer to the truth than the official government estimates, because based on people on the ground, the self-registration efforts were sort of more pronounced along the border region than inland. So again, we don't know ultimately what is the true situation or was a true situation, but at least anecdotally, it's at least plausible that the gold standard is not actually gold standard, and that this other data source might be closer to the truth. In other countries, we couldn't find subnational data, so these are estimates that we could obtain that we can't validate. So again, we sort of it's probably plausible that there's a higher concentration in Brazil, closer to the border, but ultimately we don't know how precise these are. Last thing I want to mention in this context related to Venezuela is that apart from just the absolute number of migrants and refugees, you can also get insights into the socioeconomic situation. Right? Already earlier, I sort of hinted at that the device type is the proxy for, well, let's say income, so at least some sort of, monetary wealth. And based on this, what we try here is we try actually a regression model. And here we really should show the error bars, which are quite high. But basically, the ranking of locations here is a ranking of host locations. So here's something about Venezuelans in the US and something about Venezuelans in Chile, etc. So. And they are ranked by the percentage of those Venezuelans, according to Facebook, who are using iOS devices, right? So in the US, you have a fairly high percentage of those users using iOS devices. And in Roraima, Brazil, you have a very, very low percentage using iOS devices. Now, the precise value on the y-axis is built on a particular regression model that is trained on country-level GDP prediction. I'm happy to explain that more in detail. But to a certain degree, it doesn't matter too much because we're not saying, Argentina is lower than Uruguay, right? I mean, this is not statistically significant anyway. However, what is statistically significant and what emerges in a lot of sort of different variations we tried is sort of this grouping of different host locations, right? That in all variations we tried in terms of model, et cetera, people living, in these host regions and countries would come out, at the lowest end, and people, in Spain and US would come out on top, right? So at least sort of this broad stroke characterization is probably sort of true, but the differences within these buckets is probably, or might not necessarily be meaningful. Yeah, and some references later, and I'll post some link later in the discussion. Great. So now, just elaborating a bit on the, just checking for time, on the sort of socioeconomic situation, and this is now a project with Vedran and Manuel and other contributors, right? And so here we just really focus on this idea of, hey, can we use device type and other information to map poverty, right, or spatial distribution of sort of poverty. And I'll skip the motivation. I'm sure you're familiar with the data gaps that exist related to sort of subnational poverty measures. And so here what we are trying to do is we are sort of trying to combine different data sources, right? So the first is the one that I already mentioned, sort of so how many people in a particular area use particular devices or have access to 4G and sort of these kind of things. And then we combine this with satellite imagery. In this case, we're using a daytime satellite imagery where we're using existing methods. This is not developed by us to automatically detect certain features, right? So conceptually here, I'm showing two images from Qatar, right? Conceptually, you would assume that an area where there's a park and a pool is probably better off than an area where, this is the roof of the building that you live in and where there are trucks parked outside, right? But to train a machine to do this automatically is actually non-trivial. And so for this, for the study, so we use, it's a standard sort of supervised learning setup. So what does that mean? So we have for some locations, we know the answer so we know the ground truth. In this case, it's the wealth index from DHS, right? So it's an asset-based definition of poverty. So does not look at education, does not look at health outcomes. It looks at how much stuff do people in a particular area own, right? That location for which we know the sort of ground truth, we describe two different sort of features. So on the Facebook side, this would be things such as like iOS users, but also Wi-Fi, 4G, and other sort of connectivity features. And then we have visual features from the satellite imagery, right? And then it becomes a sort of regression task. So given what we know from Facebook, given what we know from the satellite imagery, can we predict this wealth index? So we've tried this in two different countries. So in the Philippines and in India, where here the target variable will be, or the measure sort of success will be sort of R squared. So higher is better. 1.0 would be perfect. We could disaggregate by urban and rural. Okay, so let me walk you through slowly. So let's start with the Philippines, looking just what you get at only using Facebook alone, nothing else, just raw Facebook data, nothing else. So across all the Philippines, you get an R square of around 0.6. So you explain about 60% of the spatial variation using Facebook data alone. Within only urban areas or only rural areas, you're actually doing worse because there's less variability or less variance to explain to begin with. Because put very simply, urban means poor, rural means rich. Sorry, other way around, of course. Sorry, but very, very simply. So that means that there's less variance to explain with, and so it's actually a harder task. So this is why these numbers are lower than the sort of the whole variance. If you look at satellite imagery alone, you get a similar performance, but now crucially, you'll see that Facebook does better for explaining the variance across urban areas, and satellite does better to explain the variance across rural areas, right? And that makes some sense, right? In urban areas, you probably have more Facebook use to get a better signal, so like a more nuanced, more fine-grained sort of signal. And this sort of persists as you add additional features related to population density and regional dummies, consistently The Facebook data, even when you add other things, performs better in urban areas, and satellite image will perform better in rural areas. And you put everything together, you sort of get the best of both worlds. So that's great. But I should also say that there are cases where Facebook does not add any value whatsoever. So we tried this in India, and there, long story is that compared to using satellite imagery, we didn't see any gain. I mean, not to say that it didn't work well. You still explain about 60% of the variance using just Facebook alone, and goes to 70% when you explain, put in other variables. But satellite was always sort of better, and probably due to the low sort of overall Facebook penetration in India as compared to the Philippines. But one of the things you can do with Facebook data that is a bit harder to do with satellite imagery is that you can easily disaggregate your models. So here I'm now showing predictions disaggregated by age and disaggregated by education level, right? And so even though we don't have ground truth for this, right? So we train a model that's sort of agnostic of age, but then we apply it just to the older Facebook users or just to the younger Facebook users, right? And so here every dot is a location, so it's a cluster in the DHS sort of speak, right? So we would sort of see that there are some locations where, based on our model, we would predict that older people are doing better in terms of asset-based wealth, and there are some where younger people are doing better in terms of asset-based wealth. In terms of education level, it's pretty much in all the locations. People who have more than high school are doing better than people who have only high school or less, right? And so this sort of disaggregation again is harder to do with traditional data. Okay, just checking the data. Okay, timing good. Yeah, and just okay. So this sort of socioeconomic mapping we're also doing another project in Lebanon, looking at Syrian refugees. Again, I'll just sort of skip the motivation. I'm sure you're familiar with the situation of Syrian refugees, broadly speaking, but probably also in Lebanon in particular. So here, what we're using, again, we're using Facebook data for people who are living abroad. Unfortunately, Facebook does not support Syria as the country of origin because it doesn't operate in Syria due to, I think, US export regulations. But however, we can target Facebook users who are living abroad while living in Lebanon and to speak Arabic. Okay, so we're using that as a proxy, right? And we do some validation to show that this does not seem to include Palestinians and other, potentially larger groups of refugees. And so there are about 700,000 Facebook users matching these criteria out of 3.5 million Facebook users in all of Lebanon. This is just sort of a spatial distribution, right? And for many of these sort of smaller cities, unfortunately, we don't have enough data, right? So all these red points indicate basically data sparsity, right? So because there's a certain anonymity constraint. So Facebook does not report like individual user data. They never report less than 1,000 matching users. And so for like a lot of small cities, we don't have data, right? So if really is, high spatial resolution sort of, so in rural areas, unfortunately, we wouldn't be able to have anything. So in the end, sort of, so there's only like small, big, depending on how you look at it, sort of a number of cities where we have sufficient data to reason about. If you look at just sort of the skew, so this is sort of the age gender pyramid, right? Like sort of, so of course you have more younger users than older users, but you'll also see that in this population, men are overrepresented compared to women. So again, certainly not representative. We know that we're never assuming that it is a sort of, but at least we also can easily see that it is not. Whereas the overall population for sort of refugees basically is pretty much gender balanced in Lebanon overall, but for the subpopulation, it is certainly not. But then just looking maybe look at the center panel here. Again, just using the fraction of users matching these criteria using iOS devices, right? So in Beirut, you have about 9% of Facebook users who are living abroad speaking Arabic using iOS devices, but in Bekaa, it's only 4%, right? So this is on the x-axis. On the y-axis, you have the percentage of Syrian refugees who are living below the poverty line. And then you see it's almost a perfect correlation. And we're not doing any model fitting here, so it's just a single variable. But this single variable, or this is now in a leave one out cross validation sort of setting would already explain about 90% this variance. So that's encouraging, right? So modulo the sparsity constraint. So if you drill in sort of too much, you lose the predictive power. But as long as there are enough users to provide a signal, the signal you get seems to be pretty good. And then great. Okay, so the last application area or application example I want to mention relates to monitoring digital gender gaps. Just very briefly for motivation. So I think about a year ago, ITU announced that at that point half the world's population was on the internet, right? So it's like more than 4 billion internet users. But as I'm sure as you know, this is not equally distributed across genders, where in most locations are women are at a significant disadvantage compared to men, So Niger would be one of the most extreme cases, where for every woman online, you have about 3 men online, right? But on the other hand, Niger is a positive example because at least they have these statistics. Right? So there are many other countries that don't have this data to with. So with that in mind, so we started this project, which is also now a website. So I'll drop the link later. So digitalgendergaps.org. In a collaboration with the University of Oxford and with support from Data2X on filling data gaps on this issue. So just to get the point of data gaps across, so what I'm showing here now, and this is again just a screenshot from the website, is data that comes from the ITU. So this is just official data. It's not, you don't need any big data for this, nothing so on. So here, what is color coded is the percentage of women with internet access divided by the percentage of men with internet access, right? So most of Western Europe is close to equality. I think Germany lags a bit behind. It's just like 0.9 something or but it's not too bad, but still certainly room for improvement, right? But then other countries are lagging, so we had Niger before roughly at a sort of 0.3 value, right? But now there are a lot of white spaces, right? Like not even Canada is reporting, not even South Africa is reporting, let alone the rest of the African continent, right? And so we're using data from Facebook, from the sort of female to male ratio of Facebook users, to now make predictions for those locations, right? So we know the answer for some locations. We would like to know the answer for the missing locations, right? So what I'm showing you here are now predictions. So these are predictions for one particular model. We have other models. I'll walk you through those in a second, right? And so here now we would predict that Canada has basically achieved gender equality in terms of internet access. So that is plausible, right? But that many other countries probably haven't, right? So now we're trying to fill those gender gaps. Right? And so, for example, just for here's a value for India based on this particular model. The data that I showed you just now is for the so-called online model that, apart from a constant, right, sort of like an intercept, has only a single predicting variable. This is the Facebook gender gap. So it's just the female to male ratio corrected for the population. In some countries you have more men or more women to begin with, of Facebook users, right? And sort of this single variable alone explains close to 70% of the variance for countries with ground truth, right? And on the other hand, you have an offline model which uses more traditional variables, including or it could use, it chose not to in a feature selection, it could use GDP, but it also, there's data from the global gender gap report on gender gaps in education, gender gaps in economy, etc. On the overall gender gap report score. And using all of those variables, it still does okay, but it actually does performs worse. It only gets a value of just about 60% of the variance. And there are fewer countries you can make predictions for, because now you're relying on all of those indicators to be available. If you combine the two, you get the best of both worlds. You get the really strong overall performance, but now you're relying on 2 data sources to be available. So the number of countries you can make predictions for goes down further, right? So it's kind of like a trade-off, right? So how aggressive you want to be in your predictions versus how accurate you want to be, right? And the more accurate you want to be, the more data needs to be available to make those predictions. Just briefly on some ongoing work, we're also looking at the age distribution. Of course, I can imagine that maybe children are of particular or young people are of particular interest to this audience. So here I'm showing just the female to male ratio of monthly active users for different age groups, right? So it starts at 13. 13 is the youngest age that Facebook supports, where you have a ratio of, sort of girls to boys of 0.9. Then it goes down to about 0.6, and it goes back up actually. And then for the oldest group, interestingly, you actually have more women than men. This is globally. This is across all countries, or sort of. And of course, there are, this does not hold for. Actually, this sort of pattern does hold for pretty much all the countries we looked at, sort of, so in approximation. But this is worldwide. And then just one last, results slide before I wrap up is here we're also looking at the time somebody has had a mobile device. So here on top is data for people who have only been using a mobile device for less than a month, according to Facebook's estimate, all the way down to people who have been using a mobile device for more than 2 years. And then disaggregated by a biological age, right? So like 13, 14, 15, 16, or sort of, right? So what does this show? So if you look at the marginals, right? If you ignore the age and just look at how long somebody has been using a mobile device, you see that among people who are only starting to use a mobile device now, the gender gap is actually quite bad. So the female to male ratio is about 0.6, right? And this is probably due, and again, we have to look more at this because the growth is the current growth of new mobile phone users is probably strongest in countries that are less gender equal, sort of, right? Whereas among sort of those who have been online for more than 2 years, you get a value of 0.85. So not great, but certainly not as bad as it sort of could be, right? And then similarly, if you ignore the time somebody has been on using a mobile device, you get the same plot that you saw before, that it's sort of okay at the 13, 14-year-olds, then it drops to sort of 25, 26, and then it's actually higher than equality for the older age. So this is something that we're currently working on. Okay, so just to wrap up, so we have time for questions. So the type of data that I showed is, again, available not just for Facebook, but for anything that has advertising. So we're going to be happy to show you other platforms, at the end, or talk about the strength and the weaknesses of other platforms, right? So for example, for teenagers, Snapchat could be a promising platform because, at least in more developed countries, it seems to be quite popular among teenagers. You get near real-time estimates, so sort of, and these are monthly active users, so they don't change like every hour or sort of, so, but realistically every other week or something or so, they might change a bit. So for all practical purposes, that's real-time. Not to the hour, but certainly to the month. I would say. There's only anonymous and aggregate data, so I never know, and I don't want to know, right, the identities of the users. And there are also certain, which I mean, the downside of this is, you cannot drill down to an individual user, right? Like the downside in terms of sort of understanding certain subgroups better, but at least in terms of privacy, I don't see a lot of issues. But I'll talk about other issues in a second. But at least in terms of identifying individual users, I think that's close to impossible with the current setup because of this sort of smallest level of 1,000 users you can drill down to. In terms of attributes you can use for targeting, a lot. I mean, gender and age are the most basic ones. Of course, the location somebody is in, the country of origin I showed, device things related to the device type, but also the interests, right? You can look at are teenage girls in a certain country not interested in math and science, right? So this sort of thing you could do quite easily through these kind of sources, right? Sort of understanding, just sort of differences in interests among different populations. On the downsides, and the downsides are considerable. I mean, by no means this is a cure-all magic bullet or sort of so. First, there's the biggest downside is the black box, right? If you're asking, well, how exactly does Facebook know somebody used to live in Venezuela? I can speculate, sort of, and have some clues, but ultimately the answer is I don't know, right? I can speculate together how they might know, but ultimately I don't know exactly how they infer these attributes. For some things it's clear, like the device type. This is sort of metadata, sort of, so that I would trust. For other things, it's also clear, like age and gender is self-declared, and so that I would trust in quotes, sort of, or so, right? Like, I mean, I'm sure obviously people can lie, sort of, or so, but at least we understand how the attribute is sort of obtained. There's certainly, bias there, right? I mean, not everybody's on Facebook, right? And this can lead to some bizarre effects. So, for example, if you look just at India, you'll see that there are far fewer women online or on Facebook than men. No surprise there, right? But now, if you look at those women in India who are on Facebook, they are actually more likely than the men in India to have high-end devices, and they are more likely than the men in India to have, higher education, etc. Right? So if you want to extrapolate out from those women in India who are online, you think, oh wow, women in India are doing really well. They're all really well educated and rich and well off and fantastic. And of course, the opposite is true, right? So this is now this sort of this Jackie Robinson effect, right? Sort of to be on these platforms, despite all the systematic barriers so against you, you have to be exceptional, right? Like you have to be like Jackie Robinson, so the first African-American baseball player in the major leagues, right? You have to not just be average, you have to be outstanding. Like so, and so this is a type of bias we observe again and again, right? Like so that the more biased it is, the more the more you get exactly the opposite effect than from what's actually true, right? And you have to be aware of this, right? Like right? Other thing, users chat and change over time, right? So if you ask me to, will the model we have now work for the next 10 years? Probably not, right? Like so I mean, Facebook might still be around 10 years from now, but people would be using it very differently, right? So the selection mechanism, who selects in and how they use the platform will not stay constant over time, right? And so this doesn't mean that there's no value in it, right? So if you need something, now, it's, you can get these estimates very, very quickly. But at the very least, you have to be aware that your model will, not stay, stable across time. At least that's our current assumption, right? We haven't been doing this for 10 years. Maybe 10 years from now, it turns out nothing has changed, but that's the current assumption. There's no historic data available, right? If you want to know, oh, that's great. So what has happened due to COVID-19 in a certain country? Basic answer is I don't know, right? And we have been doing some data collections regularly at the country level, but if it's something subnational or very specific, I just don't have the historic data, right? Like Facebook, of course, theoretically does, but you can, through these platforms, you can only start collecting data going forward, right? And similarly for LinkedIn, Twitter, Snapchat, and all these others. And last, not least, again, on the risk of misuse of so. And this is not so much on the privacy side. It's not I don't see a way of identifying Attila personally and knowing where he went on holiday or something. I don't know how to do this, right? But what I can't do is, and of course what I showed you, is I can identify subgroups, right? And some subgroups are of course more vulnerable than others, right? And so for example, in the refugee setting, you think, oh great, can you identify ethnic minorities, right? Can you draw me a map of the Rohingya, right? Like either in Myanmar or in Bangladesh or right? And so could I? And so I tried, and the answer is no. But the only reason I cannot is that they are so disenfranchised that by and large they don't have internet access, and by and large, fortunately in quotes, they're not on these platforms, right? But if, on the other hand, as a German, you asked me to draw a map of where in Germany people are interested in Jewish holidays, I can do that, not a problem, right? I can show you a nice map of where in Germany people are interested in different, or in kosher food or something, right? Now, what you might find is probably the obvious, right? There are lots of people in Berlin, Munich, and Hamburg or right? So maybe there's nothing there, but it's not inconceivable that there might be the small village which surprisingly has a high Jewish population, which you might find out through these sources, right? And of course, that makes me uneasy, right? Like as a German and knowing about German history. So these are the kind of risks that I worry more about, rather than the individual privacy risks, more the sort of the group harm or group identification. So I want to leave time for questions, and I saw there were a lot of chat messages coming in. I'll have a look at those in a second. But if I don't get to answer your question in the next couple of minutes, please feel free to send me an email anytime. Or look at sort of the reference. And Attila, also feel free to moderate the questions. Maybe you've had a look at the questions already. Otherwise, I will have a look now myself.
I will do so indeed. Thank you so much, Ingmar. This is fascinating stuff. I know that all colleagues have been very impressed with the analysis that you presented. I've been looking at the questions and the comments that have been coming in the chat box, but please do so yourself as well. I know it's difficult to keep track of all the comments and questions while you're presenting, So I will try to start, and we will have less than 10 minutes, unfortunately. I will start with a few comments that I've seen on the chat box. One of them was more of a comment saying that can it be used, or it would be great to use this to track trends and patterns in time, which can also inform programmatic priorities. There was a question. I would just come up
Just
with
a quick note on this. I mean, feel free to send me an email. I'd be happy to work with you to set up a data collection, knowing more about the use case. But sure. Yeah.
Okay. So I will say two more. I will raise two more. One of them was about how much of the data that you're using is based on compulsory information that has to be provided to Facebook, and how much of it is based on optional data. And the third one, which was a comment, the use of Facebook data is more like using atomic energy. It may be misused or may have negative consequences, like the use of WMD. And one more comment I should mention. One colleague was saying, how exactly do we collect this data? Maybe this refers to the very first slide that you showed at the very first beginning. How exactly do you get this data?
Yeah, sure. So the I'll maybe start with this first. So the very first step is you need a Facebook account. That's required, and you need to. I don't even remember if you have to provide a credit card or not. Certainly, it's not charged, but I think you might have to provide it just in case you were to launch the advertising campaign. But then technically, there is a so-called API. So there's like an endpoint that a program can talk to. You can sort of write a program and say, how many people match these criteria? Like I would like to target young women in the Philippines to sell, I don't know, some math textbook to them. How many are there, right? And then Facebook tells you, oh, I have 50 million young women or something, right, in the Philippines, right? And so you can write these programs, and then you would get this count, this estimate of monthly active users, 50 million in return. And again, send me an email. I'd be happy to provide code snippets or to send you, documentation on how to do this yourself. On how much is on the different attributes. Yeah, it depends. So for the gender work, we're using basically just the gender sort of or so, right? So that's self-declared sort of or so. For the poverty work, we are quite heavily relying on this meta information related to device types. So that's inferred. I think that's in a sense more trustworthy than your gender. Your gender, you can declare whatever you want or sort of or so, and that's not validated. But your device type is sort of harder to spoof. And then some things like we don't know, right? Like how Facebook knows the countries you have lived in. We can speculate, right? Like sort of or so. But ultimately, I don't know. Yeah, the atomic energy, absolutely. I mean, I'm not, hopefully it was clear that I didn't paint just a rosy picture, especially at the end or sort of. So when it comes to this this misuse, yeah, unfortunately, it is possible to identify, some subgroups that you prefer not to identify, sort of, so right, yeah, I can only acknowledge that sort of. So of course, in our work, we try not to use it in the bomb building ways, but it's certainly conceivable that others have used this platform sort of so also actively, of course, like the whole election meddling, but also just to collect data sort of so for nefarious purposes. I'm unaware of anything confirmed, but of course it's possible that others have done this or might do this. If we have time, maybe there's another question. Yeah, so there's something I saw a question on R or sort of how to collect the data. Again, I will, I know there's another talk, but I think the other talk's in a different link, right? Okay, otherwise I would, will this chat live on? So then I will stick around and I will drop some links in the chat, but otherwise, please send me an email. But I will, yeah, from my end, I will drop some chats. I will also share a presentation link here, and probably also through Attila, just in case for people. But I think it was also recorded. Other questions or comments?
We will indeed, Ingmar, share both the presentation and the recording on our SharePoint site for the light guidance mechanism. Maybe I can pick up on a couple of other comments since we have a few more minutes. One question is is to do with the criteria that you use to set the level of significance that guides your predictive model, the outcome of the predictive model. There's two questions related: how reliable is the data, and that the profile data that users provide to Facebook may not be correct in many cases. And this is a question that I got before we started the webinar from someone who was not able to make it to the webinar, which is to do with different social media platforms, not only Facebook, and the use of them together. Of course, this is not anonymous, and this is anonymous and not individual data. But that question, without watching the presentation, was about whether it would be possible to combine, to merge the data coming from different social media platforms, so as to be able to increase the coverage. Because there are some people who use Facebook and not Twitter, and vice versa, obviously.
Right.
And I'm thinking maybe going with that is maybe a question could be, would you come up with very completely different results if you were to use Facebook as opposed to Twitter or other platforms? Or do they all tell the same story?
Yeah. So okay. Hopefully, I'll remember this. So first, let me go. Hopefully, go in order, and please correct me if I missed one. So on the sort of data reliability or users being truthful. So in some work, it doesn't matter. So what do I mean by this? So I'm more worried about bias than about noise, right? So you could imagine that I don't know, 10% of people misreport their gender or something, right? For whatever reason, So that's certainly plausible, right? To a certain degree, that doesn't matter as long as it's 10% in a consistent way across all the countries. Because if it is the way we're using the data in a supervised setting, that would just be absorbed in the model, So the model would sort of take care of this. So the model sort of tries to take care of these sort of bias correction aspect, right? Of course, what's more worrying is if the the bias is one way in the countries where we have ground truth, and is another way in the countries where we don't have ground truth, right? And that's quite likely because the data is, of course, not missing at random, right? And so that's something in a sense that's more worrying than just the fact that people lie, is that they are lying inconsistently, right? That in some countries they're lying one way, in another country they're lying another way, So that's unfortunately is a risk, right? And that now relates to the how precise are these models, or at what degree do you sort of trust them? It depends on the setting. So in the Venezuela setting, there was not a lot of good of ground truth available, so it was sort of used as triangulation, right? Like I hope, and certainly I was never advocating that this should be the only source of migration data in the situation, and you should just do away with everything else, right? But if this data tells you something that's inconsistent or sort of differs in a plausible way, so for example, we observed this with variation more inner Colombia than on the border, so at least it gives some evidence, right, that maybe your ground truth or another data set might not be as reliable, right? So in that setting, it wasn't, there were not even significant digits. It was more about like order of magnitude, right, or sort of trends. On the sort of, on the poverty side, right. So there, I guess it's a bit more quantitative, right? So there you can actually now start to reason, okay, is this now statistically significant, better than another baseline model, or but that's also then a bit more removed from direct applications. I say it's a bit more academic exercise where you have sort of like your regression models or to play with. And then on the combination of different data sets, theoretically possible. In practice, it depends a bit, because a lot of these data sets, of these other data sets, don't have the same spatial resolution, so they wouldn't be available, certainly not sub-city, but sometimes even not necessarily at the city level. And they might not have the same sort of variables. So for example, when it comes to country of origin, most other platforms don't have something like this. I mean, they sometimes most provide language, right? So you can sometimes use language as a very crude proxy, right? Like, for example, in Europe, most people speaking Polish probably have some link to Poland, right? But of course, the same doesn't hold for Spanish and Spain, or right? So there you could compare that with other platforms, or so it depends a bit, So the Facebook is in a sense the richest in terms of targeting, which is why we use it most promptly. Having said that, we just had a paper out like a couple of days ago, sort of or so, that also looks at Google advertising data so combines Google advertising data with Facebook advertising data for modeling country level internet access, sort of or so on. So there we do sort of see that, they largely agree. I mean, by and large, there's no major surprises, but there's some nuances where they sort of differ. And so combining the two gives you potentially also a more robust model.
Thank you.
Yeah,
Thank
I think
you so much,
yeah.
Ingmar. I'm afraid we have to end here. Thank you so much once again for agreeing to present in this webinar. We really appreciate it. This is fascinating stuff. I'm sure it has triggered many questions in everybody's minds, and we look forward to continuing this collaboration with you. So to everyone, once again, thank you very much for your participation. Thanks for your great questions and comments. Now let us please disconnect from this link, and please grab your cup of coffee, and then let's connect to the next webinar session. Thank you very much, everyone.
If the organizer can just keep the link alive, I will just answer some questions in the chat as well, just so that they are archived, sort of. So,
Ingmar, sorry, unfortunately, when I close this link, I think the event will be ended.
You have to leave. Okay.
I need to start the new one.
Okay.
But feel free to share all the links, and we will share with the
Okay.
participants. Thank you so much.
Okay, sure, no problem. Okay, bye.
Thank you very much. Goodbye, everyone.